So please give them a warm welcome. Hi everyone, I'm Stu. I'm going to talk to you tonight about a little experiment I did with AWS Platform as a Service offerings. It's a bit of an experience report, and I'm going to take you through what I did and what I found out. So I'm a co-founder of 3 Dozen, as Roy just said, so we help software teams become more effective and basically make people's lives a bit better at work, hopefully. Okay, so the experiment I had was I wanted to have a look at the AWS Platform as a Service offerings. I've not really used them before at all. My AWS experience was limited really to EC2 and S3, so they're infrastructure as a service offerings. S3 is kind of a hybrid, but there's a lot more components to AWS come online over the last couple of years. I wanted to have a look and see if it was viable for somebody with minimal AWS experience to dive straight in, look purely at AWS's offerings and be able to develop an MVP or a proof of concept out reasonably quickly, and the fact that you're looking at a new technology stack's not going to affect you too much. So that's kind of the hypothesis that I had, that it's not going to delay you in what you're trying to do. Wanted to keep the costs low because I'm doing it as a bit of a hobby project. So there's nobody funding it but myself. So spinning up a few servers, you know, it's not a lot of money each month, but can I get it really dirt cheap with AWS? So where in the past I'd have spun up those services, decided to look and set myself some constraints on AWS. So the constraints, I'm only going to look at AWS. So I'm not going to look at any frameworks that wrap around it and purport to make it easier, because I want to know for myself what problems they're actually trying to solve. If I dive straight into a framework, how do I know it's actually helped me? How do I know I'm not just kind of shutting myself into a corner? So constraints are good anyway, so I didn't just want to go off and have free rein and end up down a route of, well, what technology am I going to use for this? And spend more time sort of procrastinating on what technologies are out there and what else I could do. So it was very specifically AWS. The only exclusion to that, I'm still going to use Git, because it's AWS, they have CodeCommit, which is a component, which is a Git-based repository, but why would I want to use that when GitHub's there? So just give you a little overview of the project, not that it matters too much, but just so you've got an idea of the kind of thing I was trying to build out. So I wanted to provide an API that calculates a user's score based on some actions via a website. So kind of like Stack Overflow's scoring system. Going to produce an API around that. I already had a bit of code written on this that I could plug in, so I'm looking particularly at the AWS side of things rather than building out my functionality. So, first thing I wanted to do, define a couple of API endpoints. I had a look about on AWS, and there's the API gateway component, which allows you to build out an API via AWS. You can do that either through a GUI console or from the command line. In order to start learning what there was and what intricacies there were to the API gateway, first thing that I looked at was to set this up through the GUI. So first thing I wanted to do was basically produce a mock endpoint, just something served over the internet, returning some data. Really, really easy with API Gateway. Through the GUI, at least, I was able to click a few buttons give it a defined standard static response that I wanted returned. AWS gave me a URI, and I specified the bit after the domain. So I started thinking about the kind of schema I want in the URI as well. Thought, well, that's quite easy to test. I can set up an integration test or an acceptance test that just hits the API endpoint. So I can very quickly have a simple automated test that I can run on my developer box, hit the endpoint, prove that I've clicked the right things and I'm getting back what I expected. Quite good, because I don't want to overload my brain at the moment as well, because I'm new to these technologies. And the fact that I can just put this static response there, I can get this one little part of the component of the system working very quickly. So at that point, I decided now's a good time to start looking at automation around this. Obviously, I'd done all this manually through the UI. It's not very repeatable. I want to be able to pull this down, spin it back up as and when I need it. So, a couple of options with AWS. There's just scripting out using the command line interface, or using a component called CloudFormation, which is a component that's very specific to setting up AWS components. And it runs on AWS, and it's very, very cheap. In fact, I believe in the background it spins up an EC2 instance, but it doesn't run for very long. So you're not setting up a build environment with something like TeamCity, where you've got a server that you're having to have run for a period and is probably going to cost you a minimum of £7 or £8 a month. You can do this for cents. So far, so good. So next thing I did, I deleted the endpoint that I'd created. So I've got my failing test again. The endpoint's gone. I started looking at CloudFormation. The reason that I looked at that, I thought can script it out using the CLI. It's all procedural, not particularly nice. CloudFormation looked quite nice. It's declarative and it's desired state configuration. So essentially, you declare what you want to be created on AWS, and CloudFormation takes care of creating that. If it's been created previously, it takes care of working out what it needs to do to upgrade it. So a lot less work than having to do all that myself procedurally with a script. So into CloudFormation, can define it in a couple of languages. So you can use JSON or YAML. AWS seems quite flexible on this. So it's purely a matter of personal preference. Do you prefer looking at JSON or do you prefer looking at YAML? I ended up going with YAML because I hate the noise of JSON for this kind of stuff. If I'm writing it myself, it's great for machines to creating and parsing with a human brain. I find YAML easier to parse, although it is a bit of a nightmare with its indentations. So AWS CloudFormation deploys stacks, and I'll come on to stacks shortly, but they're a really key concept to making this work in something more than just a toy project such as this. It provides transactions around the updates. So if something fails, you don't need to worry because it'll automatically roll back to the last state everything was in. There's a lot of permissions to set up on AWS, but declaring them with CloudFormation, once you've done them once, you've got them there. Come on to in a bit how we can reuse some of those as well. But it does keep all the permissions very fine-grained to the service. So I did think about just creating one user that could do everything, which would have been very easy for me to get things up and running very quickly, but thought that's going to paint me into a bit of a corner. Let's stick with, they've obviously gone very fine-grained for a reason. Let's see how this pans out. So far, with that, we've got from the command line on my box, I can give it the template, the CloudFormation template, which specifies what components I want set up on AWS. I can give that a stack name. The stack is essentially a container. The capabilities bit, it's just some permissions that it needs in order to be able to do all this stuff, particularly around setting up the permissions. So call AWS CloudFormation deploy, triggers CloudFormation on AWS, which goes on to provision the API, which I can then call. So I can spin that up and down very, very quickly, and it's not took much effort at all to get to this point. There's a little bit of a learning curve with CloudFormation, which is more of a learning curve around what components you're going to need to set up on AWS. But we'll come on to some newer things in AWS that and CloudFormation that actually help with that shortly. Got an API that doesn't do anything, so we want some functionality out of it. So the obvious way to go is a Lambda service. So a Lambda service on AWS essentially will execute some code. You don't need to worry about provisioning servers. It takes care of how to provision it. You specify how much memory you want on that. It infers from that how much processor time to give it, which is slightly odd. But at this point in time, I'm just setting the minimal values that I can. Got a few language choices on Lambda as well. So there's some compiled languages, such as Java, that you can run on there. There's other things, such as JavaScript, that have interpreted, or .NET's on there now, compiled one, but there's quite a range of language choices. And really, it comes down to personal preference and what libraries you might want to use in your functionality. So basically, you can pick the best tool for the task and not worry about what you've built things in before. I had a couple of decisions to make at this point. So again, I set up the Lambda service through the UI initially so I could learn again what's there. The API gateway can either be used to specify each individual endpoint in your API, or it can just pass everything through with the URI to the backend Lambda component. I decided to go down that route. Reason being, testing becomes much easier. If I want to automate testing of the endpoints and do some tests from the outside, they're slow. There's a lot of deployment to do. If I handle the passing of the URIs in the Lambda function, I can do all that on my dev box. I'd know that it's going to work once it gets up to AWS, and then find a library of my choice to handle that, so I don't have to completely rewrite URI parsing. But essentially, create my own dispatcher behind the Lambda service, which feeds off to what I want it to do. So, back to CloudFormation again. In, I think about November last year, there's a small project that's come out of some experiments at Amazon that they've called the serverless application model. So what they're trying to do with this is make it easier for you to set up some basic components that give you an API that does something. So those being the API gateway, a Lambda function, and Dynamo DB, which we'll come on to shortly. Saves a lot of dancing around specifying every single permission yourself. It infers a lot, so you just say, I want an API that hits this Lambda service, and it takes care of most of the permissions around that, so long as you give it permissions to execute. There's nothing magical about this serverless application model. It's actually based in the way AWS have designed the componentization of CloudFormation. So basically, it's a set of reusable components. So it's actually a demonstration as well of how you can build up reusable components for AWS. So if you design a pattern of components that you want to reuse, you can specify that pattern in a template that you can pull into the other CloudFormation templates and reuse. It's quite easy to replace local file paths as well. If you specify, say, where your Lambda function code exists on your hard drive relative to your CloudFormation template, AWS and CloudFormation can actually replace all those local file paths with an S3 bucket after it's uploaded to an S3 bucket, which is pretty cool. Oop, might gone too far then. Yeah. So CodePipeline allows me to pull the components I've got together so far. So it acts essentially as a workflow for building and deploying code and reaches out to other AWS services, the ones that I'm using at the moment. So it'll go out to Git, pull the code down from GitHub, put it into an S3 bucket. CodeBuild can then look at the S3 bucket, and if you're using Java or .NET, build your application. We'll actually compile it and then use CloudFormation to deploy. So now we've got to a really nice automated pipeline just using AWS. So CodeBuild found you could use it not just for compiled languages. If you're wanting to do any sort of packaging, running tests, CodeBuild is one of the places you can go for that, particularly running the tests. What it does under the hood, all the build tasks run in a Docker image. So there's a set of Docker images available. You give it a build spec file, again in JSON or YAML. It undertakes all its operations on files within an S3 bucket. And it can either be used standalone, pulled directly from your repository, or it can be passed code by the CodePipeline. So CodePipeline can pull down from the repository and pass that S3 bucket where it's pulled it to through the different AWS components. So now I've actually got this doing something, I've got some functionality there, I want to start persisting some data, and this is where things started to get a little bit tricky with AWS. There's a couple of options. RDS, which is their relational database system, which actually is an abstraction around a number of other off-the-shelf databases. So you can back that with MySQL, Postgre, or Amazon Aurora, which is Amazon's attempt at creating the newest and greatest relational database system because nobody's created a good one before. Apparently, they claim it is 10 times cheaper to use it than another relational database system, but I'd like to see some evidence on that. Doesn't seem too real. But in order to use RDS, it needs a dedicated EC2 instance. So it moves away from my principle of going as cheap as I can. Whereas Dynamo DB, you just pay for your envisaged throughput. It's not quite as good as Lambda that will just charge you for the execution time, but you can scale it up and down. It's a key value pair and document database hybrid. Sounds quite odd. Basically, there are key value pairs and then a section that you can just put whatever you want into, which is your document, so you can use it as either. Okay. Dynamo DB seems to be designed around reading and writing lots of small, short-lived pieces of data. So while I've started to use it on this application, I don't think it's the right thing, and I've started feeling a lot of pain. Something that I found right the way through this journey is as soon as I started feeling pain from something I was doing with AWS, it was telling me that there was probably another way of thinking about the problem or some different way of approaching it. Which is generally a good principle anyway. If I feel pain, it's a warning sign. But I battled through with it because there was no real other option on AWS, and I didn't want to just spin up an EC2 instance and stick an other database system of my choice on there, because again, it's going to cost me 7 times the cost of what I've already built out. So I thought, stick with it, see what I can do. It's very good if you only need to retrieve data by a very specific key. It starts costing you more as soon as you put additional indexes on. You need to embrace eventual consistency to make it work, because it's kind of baked into the way Dynamo DB works, unless you pay more money. It kind of worked for what I wanted to do, because all I was doing was returning a specific representation of some data. So if I populated Dynamo DB with the data that I wanted returned for a specific key, it kind of worked for what I wanted, but I wouldn't like to look at scaling that up. It's very scalable, is Dynamo DB, but for high usage scenarios and a lot of data being in there, it's the only real way that the pricing model works for it can quickly escalate. Say if you wanted every minute 20 hits on the database, and then the next minute you don't want any hits, you're going to be paying for the capacity to have 20 hits on the database every single minute. So it can start quickly spiraling costs if you're not careful. There's other ways you can start thinking about using that on the background, so creating somewhere else for long-term persistence of your data that you're not going to access much, you don't want to query much, so for example, putting it in S3 at the same time. There's no real backup system with Dynamo DB, and if you start thinking about backups, then you need to increase the throughput on it, which again is going to start increasing your costs a lot. So it does seem there's very specific use cases with that, but you've maybe got to think out of the box a little bit to keep your costs down. So I don't think there's really a very good database storage system on AWS at the moment that keeps your costs low. I'd probably spin up an RDS if somebody was giving me the money for it, but for my own pet project, I didn't want to spend $20 a month, I want to spend $2 a month. They do claim with it that it averages out the capacity used over a 5-minute period, but they say not to rely on that, which is a bit of a weird scenario. We do give you burst capacity, but don't use it. So the final architecture that we came out with, code stored on GitHub. Either CodePipeline or a developer can pull that repository down and execute CloudFormation, which provisions the stack of the API gateway, the Lambda service, and in this case, Dynamo DB. Works exactly the same whether it's triggered by a developer or CodePipeline. CodePipeline just automates what you'd be doing as a developer. Which brings us on to CloudFormation Stacks, which I mentioned earlier. So I started looking at how can I build out a good developer workflow? How can I have a dev environment, a beta environment, and a production environment? And if you remember a few slides ago, there was a stack name I specified. That's all that you need to change to deploy separate instances of your application and pull them up and down. So long as you don't specifically or implicitly name any of your components, just let AWS take care of the naming, and then it can give them different names on your different stacks. So in conclusion, really enjoyed playing about with AWS. I think there's some really, really useful tools on there. There was pain that I felt but that pain pushed me in the right direction. I found it fantastic for taking an outside-in approach without having to think about too much at once. So I started with just that little API returning some static data and gradually built it into a fully featured API. Once you've defined a pattern of components, which doesn't take too much effort, you can really concentrate on the functionality, reuse what you've already done. So that pain that you feel quite early on, you're not going to have to feel again. I found while I was doing it and I was running into the pain points, just talking through to somebody what I was doing, even if they weren't a technical person, just the act of talking it through helped me sort of cement in my mind whether I was doing the right thing or whether I needed to take a different approach, which I tend to think, for me anyway, is a good way of dealing with problems. I found the best thing to do, taking an easy route to experimentation with it. Don't try and overload your mind too much with too many different concepts at once. Get it doing something and then work out how to make that a bit easier. A really good thing, there was no downtime in any of the deployments while I'm pushing out to it. It'll build, it'll redeploy. If there's anything running on an older version, that will complete, and then the next call will flip over to your new version. So really easy to get a great pipeline, great developer workflow set up. So overall, pretty good. Yes, could run it pretty cheap. Didn't take too much effort to get to this point. So I felt that you really could throw a new project and some new developers at it that hadn't used it before and get them productive pretty quickly. Thanks, everyone.